Hello and welcome to Math Made Simple. My name is J. Akwedabo. Today we'll be looking at sequence and series, their respective meanings, basic types, associated equations or formulas, and we will also be solving sample problems. So please stay until the end of this video. Please like my video or subscribe to my channel. A sequence is simply a list of terms. If the difference between successive terms is common, like in the case of number 1, we have 1, 3, and 5. The difference between 1 and 3 is 2. 3 and 5 is 2. So meaning successive terms have a common difference. We call such a sequence an arithmetic sequence or an arithmetic progression. If successive terms have a common ratio, we call such a sequence a geometric sequence or a geometric progression. If we intend to find a particular term of an arithmetic sequence, we use the formula Tn equals T1 plus D into n minus 1. Tn is that term, T1 is the first term, D is the common difference, n is the number of terms, and minus 1. If it is a geometric sequence, then we use this equation. Tn equals T1 multiplied by r, which is the common ratio, to the power of n minus 1. Then on the other hand, we say series is just the sum of the terms of a sequence. Finite arithmetic series, that is derived directly from the arithmetic progression. And we have finite and infinite geometric series that comes from a geometric progression. For the formula for arithmetic or finite arithmetic series, we have Sn, which is the sum, equals n, the number of terms, multiplied by T1, the first term, plus Tn, the nth term, divided by 2. For finite geometric series, Sn is T1 into 1 minus r to the n power. This r is the common ratio divided by 1 over r, where r is not 1, because when r is 1, in the denominator you will have 1 minus 1, which is 0, and this entire term will turn out to be undefined. For infinite geometric series, which is a special case, the absolute value of r must be less than 1. Considering the general equation of a geometric series, you would think that as n gets bigger, the value of Sn will also get bigger. But considering the restriction of an infinite geometric series, where the absolute value of r must be less than 1, meaning the value of r must be between -1 and 1, excluding 0. In that case, as you increase the value of n, like in this case, we've increased the value of n from 2 to 4 to 10, where we consider our r value as 1 over 2. What happens? Let's see. So, if the value of r is 2, for in this case, we say 1 over 2 raised to the 2 power is 1 over 4, which is 0.25. When we increase that value, the n value, to 4, we have 1 over 2 to the 4th power, which is 1 over 16, which is 0.125. If we increase it to 10, we have 1 over 2 to the 10th power, which is 1 all over 1024, which is 0.00098. Now, we see that as we are increasing the value of n, r to the n power is going to 0. So, there's this general concept that as n goes to infinitive, the value of n to the r power will go towards 0. So we consider this to be 0 for infinite geometric series, meaning our Sn is just simply T1 over 1 minus r, which is this equation. A series may also be written using the Greek symbol sigma, which is written in the sigma notation form, where n equals k, and this k is the start value of n, and n is the end value of n. And of course, you know n is the number of terms. So problem 1, find the 16th term of the AP 2, 9, 16. B, find the sum of the first 30th term. T1, which is 2, D, which is 9 minus 2, or 16 minus 9, which is 7, which is the common difference, and it's 16 because they're talking about the 16th term. And Tn, or Tn is T16, and we have the sum of the first 30th term, which is S30. Solution. The equation, since this is an arithmetic progression, is Tn equals T1 plus D into n minus 1. And our Tn is unknown. So we have T1, which is 2, D is 7, n is 16 minus 1. 16 minus 1 is 15. 2 plus 7 times 15 is 105. 2 plus 105 is 107. That is our 16th term. And B, our n is 30. 2, which is T1 plus T30, because we do not know T30, divided by 2. So we need to find our T30 before coming back to this equation. But our T30 is T30 equals 2, which is the first term, plus 7, the common difference, 30 minus 1. This will give you 205. So we substitute this 205 in this equation, which will give us 30 into 2 plus 205 divided by 2. So 30 divided by 2 is 15. 2 plus 205 is 207. 15 multiplied by 207 will give us 3,105. That becomes our T30. If the 14th term of the AP is 96 and the 25th term is 173, A, find the if term. B, find the sum of the first 20th term. We have our T14 as 96, T25, 173, and A is asking for T8, B is asking for S20. Since this is an arithmetic progression, we use this equation, the general equation for the nth term of an arithmetic progression. Using our T14, we have T14 equals T1 because we do not know T1, plus D, we do not know D, into 14 minus 1. 14 is from the 14th term. Then we have T14, which is 96, equals T1 plus 13D. 14 minus 1 is 13. 13 times D is 13D. This is our equation 1. Then we take our T25. T25, which is T1 plus D into 25 minus 1. But our T25 is known, is 173. 173 equals T1 plus 24D. 25 minus 1 is 24. Multiplied by D is 24D. So this becomes our equation 2. So we have simultaneous equation in two variables. So let's solve this simultaneous equation by multiplying the first equation, equation 1, by minus 1. And when that happens, you have minus 1 times 96 is minus 96 equals minus t minus 13d. So you add the two equations, you have 77 equals 0 plus 11d. The question is, why do we choose to multiply equation 1 by minus 1? The reason is we have t1 in both equations with a coefficient of 1. So in order to eliminate one of the coefficients, what you have to do is to multiply one of the equations by -1. Then you have one of the term being eliminated, like we can see here. T minus t1 plus t1 is 0. So you have 77 divided by 11 is d. Now we use this d substituted in equation 1 so as to determine t1. So 76 equals t1 plus 13d. Substituting d, we have 13 times d, which is 7. And our t1 becomes now 96 equals t1 plus 91. You transpose this, it becomes -91, and t1 now becomes 5. So we use the d and the t1 as we have solved and use it in our general equation to solve for t8. So t8 becomes 5 plus 7 into 8 minus 1. That gives us 5. 7 minus 1 is 7. 7 times 7 is 49. 5 plus 49 is 54. That becomes our T8. Now B, we go to S20. S20 is just simply 20 into 5 plus T20, because we do not know T20 divided by 2. So we need to go ahead and know the value, solve for the value of T20 before using that value into this equation to solve for our X20. So our T20 becomes 5 plus 7, which are values that we determined earlier, into 20 minus 1, T20. So n is 20 here. 20 minus 1 is 19, times 7 plus 5, that gave us 138. Now we use this 138 into this equation. S20 equals 20 plus 5 times 5 plus 138 divided by 2. 20 divided by 2 is 10. 5 plus 138 is 143. 10 times 143 is 1,430, which is our answer for S20.